Welcome to everyone joining us from the last discussion and to the people now just tuning in to the summit. My name is Billy. I'm the Academy Manager here at OneClick LCA. This session is optimizing EPD creation and streamlining LCA workflows, lessons from Trimble. I'm joined by OneClick LCA's training lead, Marius Tsikos. He'll kick off the discussion with a short lesson on environmental product declarations and their role in lifecycle assessment. He'll then hand over to Sakari Lahti from Trimble, who'll show a real-world example of how manufacturers might incorporate EPD creation into pre-existing workflows in a more streamlined way, particularly where more complex products are concerned. But before we start, let me quickly provide some information about the summit for those joining us for the first time. This Summer Sustainability Summit is brought to you by OneClick LCA, the global LCA software empowering the industry to decarbonize and get sustainable. Gain access to the world's largest construction LCA database and bring LCAs seamlessly into your existing workflows with more than 20 BIM and other tool integrations. Stay till the end of the session for more information about OneClick LCA. And now about our guest, Trimble. Trimble is a global technology company that connects the field with the office across the world's most essential industries. With a core desire to solve the big problems of the world, Trimble develops innovative technology to help achieve this. We connect the physical world, or they connect the physical worlds, to deliver value to our customers in terms of productivity and sustainability. To put it simply, Trimble enables customers to get their work done faster, safer, cheaper, and greener. Trimble's headquarters is located in the USA, and they're listed on the Nasdaq stock market. But many people in Trimble's structures division are located in Finland, as they joined Trimble through the acquisition of Tekla back in 2011. Yeah, and quick introductions. Hello to Marius Tsikos.
Hi everyone, hi there.
And to Sakari Lahti. Sakari has been working with sustainability initiatives related to structures at Trimble. He has an MSc in structural engineering with work history in structural engineering, but now over 10 years at Trimble. Sakari, hello.
Hello.
Okay, I will now hand you over to Marius Tsikos, who's going to begin this session, as I mentioned, with a short lesson on the theory behind LCA and EPDs. Marius, take it away.
Thank you very much, Billy. So before we start, let's do a very quick recap of what is lifecycle assessment first, or LCA as we call it. So LCA is a standardized methodology that allows us to calculate the environmental impacts of any product or system throughout its entire life cycle. So in our case, this product is a construction product or a building or an infrastructure project. And focusing on building LCAs and infrastructure, the life cycle focuses on the raw materials extraction like limestone, iron ore, and so on, the transportation of these materials to the manufacturing site, the manufacturing process itself, and the associated emissions. So turning this iron ore into steel or this limestone into cement, the transportation of these construction products now from the factories to the construction sites, the construction process itself in A5, as we call it, which is associated to emissions related to energy use mostly, but also material waste. And then we've got what we call the U stage, which is impacts related to materials, replacement of materials, maintenance, repair, but also operational impacts like energy and water use. And then after 50, 60, or 100 years, or anything like that, when the building reaches the end of its service life, we've got what we call the end of life stage, which starts with the module C1, which you can imagine it as the opposite of A5, so it's impacts related to the deconstruction of the building. Then again, we've got the transportation related emissions for getting these deconstruction products to the various recycling facilities or landfills. And then we've got the waste processing related impacts at C3, so turning this steel scrap into recycled steel. And then we've got the landfill related emissions. So if we get some materials and they decompose in the landfill, they will start to emit greenhouse gases, which contribute to global warming and several other impact indicators, as we call them. And finally, we've got module D, which we call the benefits and loads beyond the system boundary. So in this module, we're trying to capture the benefits from recycling or reusing materials, or even incinerating them and recovering the energy out of it. In our case, this product that we were just discussing is any building or any construction, really. It could be an infrastructure project, and of course, any construction product. In the case of a construction product, first, the results of an LCA, when they are verified, reported, and published, is what we call an environmental product declaration, or EPD in short. It is something that construction product manufacturers do for their products for various reasons, which include helping customers to achieve building certifications and comply with local regulations. It also allows the building designers to undertake a building LCA, compare different products, and specify them. EPDs are also a powerful marketing tool for manufacturers who can demonstrate that their product is a lower environmental footprint than a benchmark or than another product. While in addition, it also helps manufacturers to benchmark their products and improve those products in the future. EPDs are used in commercial certification schemes like LEED and BREEAM, and they award credits and points for specifying products with EPDs. And this is easier and more cost efficient when compared with achieving some other credits in these rating schemes. So it is an easy credit to get in these schemes, and this is why it is quite popular. Often, more credits will be provided for EPDs from manufacturers that are specific to this product rather than generic. And then we also have the optimization credits or points or optioneering points, where the building can get extra credits or points if they also undertake a building LCA and try to do some optioneering or even reduce the embodied carbon at a building level. So this can be achieved by choosing products with EPDs that show lower environmental impacts in this case. In addition to certification schemes, we also have regulations. We have local policies and national building LC methodologies where EPDs are required. We're not going to go through all of these, but as a reference, we've got regulations in countries like France, Sweden, Finland, Denmark, Norway, and we've got local policies like the whole life carbon policy in the London Plan. And when it comes to client drivers, we could distinguish them into two types, basically. The clients who require to use the EPDs because they want to demonstrate compliance at a billing or other entity level, for example, for billing regulations or certification schemes, as we just said. And then we also have clients who will require to use the construction products with EPDs, and in many cases, products with certain carbon performance in order to take part in public tenders. Despite the obvious market push to present an EPD currently, we must also look to what is coming. So what is next? There's going to be a lot of regulations in the future, which is going to be difficult to maneuver and understand. But in summary, we've got global guidances and regulations, guidances like Global Alliance for Buildings and Construction, or aspirational goals from the World Green Building Council and several initiatives for decarbonization in the built environment. Then we've got at the EU level, We've got the Green Deal for a neutral 2050, carbon neutral economy by 2050, and we've got the carbon border adjustment mechanism that promotes EU made products or applies a carbon tax on foreign imports based on CO2 impacts, which of course will need to be validated with EPDs. And then we also have the USA with various bike clean acts, with California, for example, also stating numerical carbon limits for some products, and now bike clean iterations in Oregon, Washington State, Minnesota, Colorado, and New York State. And on top of this, we've got the Inflation Reduction Act and other initiatives that will drive the increase of EPDs in that region. Finally, before we move on the billing LCA process in general, I just want to show this graph, which is created by Jane Anderson, which shows the exponential increase of construction EPDs, in this case EPDs that are complying with the EN 15804 standard. So we're just at the beginning, I would say, and we will see these numbers increasing very significantly in the coming years. Going now one step back and the use of EPDs in construction LCA, we said that this is one of the main drivers for EPD demand. But why is it so? If we look at this fairly simplistic definition of construction LCA calculations, the impacts of a building or an infrastructure project are calculated by basically multiplying the various construction material quantities with impact factors, for example, kilos of CO2 equivalent per cubic meter of that material. So quantities can be taken from design documentation. That's the first part solved. But what about the emission factors? This is where we need the EPDs. They are public documents that declare the impacts per declared unit for the various construction products. And by multiplying these material quantities, for example, for stage, for modules A1 to A3 of an EPD, then we get the A1 to A3 share of that product in the billing LCA. So we could say that EPDs are basically enabling the construction and billing LCA as they are providing the data on these impact factors. And as construction LCA is becoming more mainstream, so will be EPDs as well, because there will be much higher demand for EPDs. And there will be higher and higher demand for EPDs across the world because the building regulations are becoming tighter. Just as an example, the new EPBD directive, the Energy Performance Billing Directive in the EU, will constrain national regulations from 2028 and onwards to perform billing LCAs for all new billing projects. And soon thereafter, there will also be limit values imposed for these billings. So EPDs, and especially EPDs of low carbon products, will be in very, very high demand. How else are EPDs used in construction LCA? They are used to compare different products, benchmark performance, and also specify low carbon products. In this slide, we can see how one-click LCA users, for example, they use the EPD database from one-click LCA to find EPD benchmarks in their own countries and the wider region, and how to find lower carbon products than those benchmarks. And of course, once a manufacturer has created their EPDs, they will also use it as a pretty strong marketing tool. It is a manufacturer's way to communicate their commitment to their sustainability targets and also to differentiate from the competition. Pretty much the same drivers apply for billing and construction LCA, of course. In summary, these are the national and regional regulations, rating schemes like LEED, BREEAM, Green Star, and others, but also aspirational targets set by World Green Building Council, for example. We mentioned in a previous slide that we gave a very simplistic definition of the billing LCA calculation, that quantities times impact factor. In real life, the basic steps for undertaking a billing LCA starts with familiarizing with the billing design first, collecting the material information, then, which is one of the main types of data that we need, that covers the quantity, getting other data like energy and water consumption, and again quantity related but from different sources, then taking the results, analyzing them, and doing further iterations to reduce the whole life impacts. And when should someone start this process then? The answer to that question is very simple. It is as soon as possible, because it is at the earliest stages that we've got the higher ability to influence the design. It is at the earliest stages, for example, that we can influence the design. We can convince the design team and the client that we need to switch from one structural frame to the other, or we need to change the shape so it is more efficient, or do any other such big change. And as we move on, we leave smaller changes like window types, flooring, and choosing products for later design stages. To translate the previous graph into impact reduction, as the ability to influence the design reduces, so does the decarbonization potential as well. And this is why we need to start early, especially with these bigger items like the structural frame, the slabs, and the foundations. And how can we streamline this process as much as possible? By using BIM integrations in order to automate this material and other gathering. Um, so we can focus on the actual LCA modeling and then the optimization of the building performance. Sources of data can be quite many, really, but today we will focus on data sources for structural materials, in which case the one-click LCA integrations with Tekla structures and Tekla structural designer, they can be very useful. And with that, I will hand it over to Sakari, who will talk a bit about these integrations and how Trimble's tools have been proven very useful for prefabricators as well, who wish to produce EPDs for their products. Sakari, over to you.
Great. Thanks, Marius. And thanks for having me. It's a real pleasure to be here, and I want to thank you all listeners also who have joined this session. So many of you out there might be figuring out still your LCA and EPD workflows, and the problem is that there are too many manual steps often between the solutions, and the data quality to do that EPD or LCA report, the quality might not be sufficient enough, and that might lead into insufficiencies and errors in the process. But with Trimble, you can get accurate data seamlessly that will make your LCA or EPD processes faster and more reliable. So I'm going to show you three practical use cases about utilizing LCA and EPDs as a method to do sustainable design. And for that, you will need the right innovative tools and the integrations to make that process sufficient. So first, emphasizing the same thing that Marius was talking about. So why you need to have efficient tools and integrations? Carbon reduction potential is always higher the earlier you try to optimize your design. And therefore, you might lose an opportunity in a traditional processes. And ideal would be to utilize the tools that give you fast impact and fast feedback on the embodied carbon and structural design involved early phase of the design development. More iterations you can run against different value parameters, more insights you will have to make better decisions. This type of design development will, of course, need new transformational attitude from all the stakeholders, owners, contractors, manufacturers, and of course, the entire design team. But when optimizing the entire building level embodied carbon, the data integration to LCA software needs to be fluent, but also feed the correct data. And with Trimble, there are three different use cases how to feed one-click LCA with the data. First option is directly from the structural analysis software which is called Tekla Structural Designer from Trimble. And the second option is from our constructible BIM modeling software, Tekla Structures. And the last option is our project collaboration platform called Trimble Connect. And these options provide a feasible data transfer regardless of the project setup. After data is imported to one-click LCA, you can get the building LCA that can be used as a benchmark to reduce the embodied carbon with the project stakeholders by changing the design or the construction materials. So all of that is kind of happening on the building level optimization. But then inside kind of each designer of the project can optimize between the building optimization, trying to optimize their own design. And with Trimble, we offer tools for Tekla Structural Designer and Tekla Structures to dynamically see the embodied carbon of individual structures. And user can define or download embodied carbon factors or EPDs used in the calculation. And the idea is that the structural engineer would get basic understanding of their design choices related to the material selection and the structural system impact on the material quantities, and of course the embodied carbon quantities. You can find more information about these tools from Tekla website if you want to learn more. There is few webinars regarding those. But then back to these use cases between one-click LCA. So 3 different scenarios. First one, structural engineer using Tekla Structural Designer for structural analysis and exports the data for the LCA. In the second one, structural engineer or BIM technician often uses Tekla structures to create a structural BIM model and exports the data to one-click LCA to do the actual life cycle assessment. And the last one being where an LCA expert might use Trimble Connect to gather the data from multiple different sources and combining multiple different models, again, to send the data for one-click LCA. So the first use case is with Tekla Structural Designer, and that is the most easy to learn structural analysis and design software for steel, concrete, and timber. It has a support for Eurocode, US, Indian, Australian, and the British standards. In the next slide, you will see how easy it is to submit the structural analysis level material takeoff to one-click LCA. So after structural design of the structural members has been done, you'll find the one-click LCA button from the integrations tab page. It exports the material takeoff to one-click LCA and opens a web browser to continue with the data. Notice at this point, it is possible to send the data to another user. So it means that it doesn't need to be the actual structural engineer utilizing the one-click LCA, but the data can be sent to the assessment done by another user. And this speeds up the iteration of building design as the structural model is utilized before any official documentation is needed. Then the second use case is with Tekla Structures. And Tekla Structures is a powerful structural BIM software that lets you create, combine, manage, and share multi-material 3D models packed with valuable construction information. You can use Tekla Structures for any project type, any material throughout the project, from conceptual design to the constructible level of detail. So the key difference is that Tekla Structures has been built for constructible BIM modeling. It means that every nut, bolt, weld, connector, or rebar can be easily designed. Here's one practical example of the difference that is important from the LCA point of view. Tekla 3D model really represents how structure will be built. Therefore, the material quantities are always correct, and it does not contain any overlapping materials. In the example structure here, there is a 4% difference in volume of concrete compared to alternative BIM software. So inaccuracies in the data input for the LCA can distort the results, leading to bad decisions or time wasted on LCA software to fix the input quantities. Tekla model can offer geometry accuracy, correct material data, object hierarchy, and data reliability for the LCA and EPD definitions. And no matter what material you're working with, we're actually talking about truly constructible models. At Tekla, we have focused on steel, cast in place, and precast concrete. However, our customers have taken Tekla platform and created their own tools, for instance, to aluminum curtain walls, light metal framing, and timber structures, etc. And they have selected Tekla because it's the only platform that can perform with fully detailed structures. So it is the tool to get the most accurate material takeoff. And for all building component manufacturers, it means accurate data to understand all parts and pieces that are needed to prefabricate those components. In EPD definition, you're trying to figure out the average consumption of materials for building components per kilogram of material or square meter of area. If you use Tekla to create constructible BIM models, you will have that information. You are able to get the average amount of welding in a steel truss product per kilogram, able to get average amount of certain embeds or reinforcement in a certain precast wall panel per product kilogram. And the following slide shows the integration from Tekla structures to one-click LCA. So to get the data for LCA from Tekla structures, there are two workflow options. First one being the same as with the Tekla structural designer. Information can be sent to a LCA expert via send to another user feature. Other option is that the LCA expert accesses or creates the BIM model for LCA purposes. Modeling tools in Tekla are very easy for anyone to create BIM models, especially for LCA purposes. Third use case is around Trimble Connect, which is intuitive collaboration platform for construction projects. Trimble Connect is a cloud-based platform that connects the right people to the right constructible data at the right time. It provides up to the minute construction-ready project information. View, review, and reference BIM models, drawings, and other data you'll need for a successful construction project. Trimble Connect has a web 3D viewer to assess 3D models of the project done by different stakeholders. In the video playing on the screen, there are one model created by an architect that contains exterior wall panels and a roof structure. One model is created by the structural engineer that contains the foundation. And another model is created by the steel manufacturer that contains the steel frame of the building. All data from those models can be sent to one-click LCA via the web integrator. This gives the freedom for the LCA expert to collect the models regardless of the design software that can export open BIM IFC format. Having a 3D viewer tool in the LCA process helps the LCA expert to understand the design better when assessing the carbon impacts. So that was a brief introduction to the tools and the integrations from Trimble to help in your LCA and EPD workflows and to reach your sustainability targets. And I hope you found the content interesting. So thank you for my behalf. And now I guess back to Billy.
Thank you, Sakari, and thank you, Marius. If there are three key points we'd like you to take away from today's sessions, it would be these on the screen right now. So that's LCAs and EPDs are fundamental components for us to attain net zero targets. More efficient workflows enable early design iterations, particularly where teams must integrate EPD and LCA creation in well-established processes. And data accuracy and reliability is the key challenge to overcome. This rings true across all the work we do here at OneClick LCA. But before moving on, we want to quickly announce a new course that's coming soon to our online training academy, OneClick LCA for structural engineers. This is being produced in collaboration with the team over at Trimble, and we will give a comprehensive overview of the theory behind LCAs and cover the Tekla structures integration with OneClick LCA. We have time, I think, to ask our guests one question each. The first one is to Marios. So, Marios, can you summarize briefly what are expected to be the future drivers for the creation of EPDs?
Yep, absolutely. Well, that is going to be more regulations, really, more regulations and more policies. Regulations to undertake building LCAs or infrastructure LCAs. In general, we already have such regulations in many countries here in Europe. We also have them in California, in the US. I'm pretty sure that it will happen. It will be a thing in many other regions from across the world, and it will become a thing for all countries in Europe in the next few years because of the new EPBD directive. As we said, it will require all EU states to integrate LCA requirements within their building regulations, and there will also be limit values applied. So it's not just gonna be do an LCA kind of regulation, but do an LCA and make sure that it also has low embodied carbon or lower than it should be to make sure that we are going to achieve our national targets for 2050 or our targets as European Union. Then we've got regulations that will mandate the use of products with EPDs, like these buy clean policies in the US, in California, and several other states. It is something that is more popular in the US. I'm pretty sure that this will happen in the rest of the world as well. There are a few countries in Europe that have such requirements for public works that mandate that all products should be coming with EPDs. And at the next stage, it will also be products with certain performance for the various material types. So it would be all concrete products should be less embodied carbon than that benchmark or something like that. So this will drive the demand for more EPDs, either directly, like in the second case, or indirectly through billing and infrastructure LCA indirectly. Yeah, that's that.
Thank you, Marius. That was a great answer. To Sakari, who just have the one question, which of the Trimble integrations would you say is more suitable for early stages where carbon reduction is more impactful?
Right. Thanks. Yeah, I think all of the integrations can be used in the early stage of the design, but probably kind of in the very traditional process, structural engineering happens kind of at the early phase. So probably Tekla Structural Designer would be the most optimal tool to use at the early phase. But even in Tekla structures, you can use it for conceptual modeling, even though it's not like for structural analysis, but to get the basic understanding of the structures. And of course, Trimble Connect being the one who collects the early phase designs from multiple sources. So depending on the role and processes, but Tekla Structural Designer is the most obvious one in that sense.
Yes, and I think anyone who joins the upcoming course will get to see that in action. Thank you very much, Sakari, for your time today.
Thank you.
And thank you to Marius.
Thank you, Billy.
Before anyone heads to the next session or heads off, I'm going to leave you with a couple of links. To learn more about Trimble or Tekla, or to ask any questions about anything you've heard in the session today, you can pick up your phone and scan the QR code that will show on screen here, and that will take you to Trimble's site. There's also, as Academy Manager, I guess I'm obligated to mention the hundreds of hours of on-demand course materials at OneClick LCA Academy and our live week-long boot camps that provide a comprehensive overview of EPD and LCA concepts. These are expert-led and very cover both theory and practical demonstrations, so you can get hands-on. You can enroll for the next one via this QR code on the slide or by visiting academy.oneclicklca.com. There's also the OneClick LCA Low Carbon Manufacturing Awards 2024 that celebrates sustainable practices and low carbon solutions in manufacturing. It's open to manufacturers of all sizes across all industries, and this contest is your opportunity to gain global visibility through extensive media exposure, benchmark your product against peers and competitors, and win more business. Scan this QR code if you want to find out more. And apply to the contest. If OneClick LCA sounds like a solution for your needs, our business team of carbon experts would love to provide a tailored demo to show you how our software might work in action. If you're joining us from the Livestorm environment, you should see a poll on screen now asking, do you want our business team to contact you to schedule a free custom demo of OneClick LCA's software? That is, if you would like to book a demo and get advice on decarbonizing, you click yes in the poll that you can see there. When you click yes, we'll get in contact with you to set up a call. Finally, we are always happy to hear from you. If you would like to contact OneClick LCA, please visit oneclicklca.com, or to learn more about the construction and manufacturing LCA software, you can write us directly as well via sales@oneclicklca.com. And you're also welcome to follow us on LinkedIn and YouTube. Check out our content there about decarbonizing the industry. That is all for now. Thank you very much to everyone watching and to our guests. See you.